Hello students, how are you all? Today we will discuss about the nature of a convex lens. Yes, we will discuss all about a convex lens, and we will also see that if a ray is passing through a convex lens, then how the ray will behave after passing through that lens. For that, we need to draw some ray diagrams. Let's see that. First of all, this is called a convex lens. Yes. Now, in this convex lens, this point is called optical center. Yes, optical center or pole. So this point is optical center or pole. Now, if I ask you the definition of optical center or pole, you will say that actually this is the only point of a lens through which if a ray goes, then the ray goes undeviated, means the ray does not change its path. This is the only point. If a ray goes like this, then it will go in the same direction. It will not change the direction. Actually, other points are also there in the lens through which if ray goes, then they do not go the same direction. They changes their direction. That we'll discuss later. But this is the only point, one and only point of the lens through which a ray goes. That ray goes undeviated, means the ray does not change its path. So if I ask you the definition of pole, you will say that pole is the only point through which a ray goes undeviated, means the ray does not change its path. I hope pole is clear. Now, so number one we discussed pole. Number two, this is the lens. Now I can consider that this portion is the part of a circle. See, you have to imagine the circle. I can consider that this part of this lens is the part of a circle, and this part is also the part of another circle. So just you have to imagine two circles. Now, center of those circles, these two are centers. Say this is C1 and C2. This is the center of this circle. This is the center of this circle. These centers are called center of curvatures of this lens. Got it? Center of curvatures of this lens. So we got this point which is called pole or optical center. You can denote it by O. Now, if you join this center of curvature, pole and other center of curvature, you will get a straight line. We call it principal axis. Say XY is the principal axis. So you understood C1 and C2, which are called center of curvatures, and O is called pole, and this line is called principal axis. Now let us rub this portion. Now, next thing is, if you pass a ray of light, the path of this ray of light is parallel to this principal axis. The condition is the path of this ray is parallel to principal axis. In that condition, you will see that this ray is going through this direction. Yes. Say I am taking another ray which is also parallel to this principal axis. Then you will see that after crossing the lens, again it is passing through the same point. if you send a ray from here, then this one is also passing through the same point. We call this particular point focus point. Got it? Focus point. Now, so what the condition I said? The condition is if these rays are parallel to this principal axis, then after crossing the lens, they will pass through a particular point of principal axis. That particular point we called focus point. Now the focus point is not over yet. For this, I will draw another diagram. See, again, convex lens, pole, center of curvature, another center of curvature, and this is called, yes, principal axis, xy. So I told you, if a ray is parallel, if this is a ray which is parallel, then they will pass through a particular point. We call it focus point. Now, in the same way, if you think it in a reverse way, that there is a particular point through which if you send a ray, there is a particular point, only one point is here. It's a special point through which if you pass a ray, after crossing this lens, the ray will become parallel to this principal axis. Same way, if you pass another ray like this through that particular point, then again you will get a ray which is parallel to this principal axis. If you are sending another ray, then again you will see that this ray is also parallel to the principal axis. So it's a special point. We will also name it as F. Actually, we call it first principal focus, F1, and we call it second principal focus. First principal focus, second principal focus. Got the point? Now, so first we discussed pole, O, pole or optical center. Number 2, we discussed center of curvature, C1 and C2. Number 3, we discussed principal axis, XY. Then we discussed F1 and F2 and F2. F1 is the first principal focus, is a point through which if a ray passes, then that ray becomes parallel of the principal axis. And F2 is that point, this second principal focus is that point if a ray is parallel to the principal axis, and after passing the lens, it will pass through second principal focus. Yes. So we know what is called pole, center of curvatures, then principal axis, then first principal focus and second principal focus. Now, if I draw this figure again, convex lens. So this is my pole and this is my principal axis. So here is the center of curvature and here is another center of curvature. And this is called focus point, first principal focus, and this is called second principal focus. Got it? One more information. According to the syllabus of class 10 standard, we have this lens where this focus point is exact midpoint of O and C1. You got my point? I repeat. F1 is the midpoint of O and C1. In same way, F2 is the midpoint of OC2. Got it? Now, the distance between F1 and O is called focal length. We denote by small f. And the distance between O and F2 is also called focal length. The distance between pole and center of curvature is called radius of curvature. Same way, the distance between pole and center of curvature is also called radius of curvature. So we got focal length. Focal length means the distance from pole to focus point. What is called radius of curvature? Radius of curvature means the distance between pole and center of curvatures. Got it? And all the distances we measure from pole. Remember this. All the distances we always measure from pole. And as I told you, F1 is the midpoint of OC1 and F2 is the midpoint of OC2. So I can say that R equal to 2F. This is the relation between radius of curvature and focal length. So if I ask you, or if you get a question in the exam that what is the relation between radius of curvature and focal length, you have to write this relation. R is radius of curvature and F is focal length. Got it? Fine. Now we will see how this ray behaves when they passes through this convex lens. Let's see that. Number A. This is a lens. We know that this is pole, principal axis, center of curvature, another center of curvature. First principal focus, second principal focus. Now, I told you before that if when a ray passes through pole, that goes undeviated. It goes through the same direction. Actually, pole is the only point. I told you in the definition of pole, pole is the only point through which if a ray goes, that ray goes straight without any deviation. Number B. Again, center of curvature, focus point. Again, another focus point, center of curvature. Now, if a ray goes parallel, I told you before, if a ray goes parallel to the principal axis, then after crossing the convex lens, that will pass through focus point. Got it? Number C. Again, convex lens, principal axis. Now, if a ray is passing through the focus point, if a ray is passing through the focus point, then after crossing the lens, that will go parallel to the principal axis. Understood? Number D. Now, if a ray is passing through center of curvature, yes, if this ray is passing through this first center of curvature, then after crossing the lens, it will pass through another center of curvature, like this. Okay, so if it's passing through first center of curvature, then it will pass through another center of curvature. So these four diagrams you have to know for to study further about this lens. Now, one more information for you. Always we will send our rays from this side, from the left side. This is the rule of physics. The rule is always we will send the ray from the left side. You will not send your ray from the right side. Always see in all the diagrams, I'm always sending my ray from the left side of the lens. This is the lens. From here I'm sending the rays. You will never send your ray from this direction. I hope you understood. Thank you.